Hello everyone, this is Bob with Edworks, and today we're going to do a technical video on wiring Jim's ProLight to the Masso G3 Touch. This is a very technical presentation. I would not consider it particularly exciting. We kind of go over the details of how we went about organizing and wiring the ProLight so that it could communicate with the Masso G3 Touch. To give you a notion of what we're dealing with here, I have a picture of the inside of the box. On the back side of the box, there are connectors DB9, DB15, and DB25. There's actually two DB9s. And the wiring that comes off of these things comes out of a cable and then goes into this box. The cable has pin numbers associated to wires. These wires have specific colors. Once you get inside this box, you have pin numbers associated to different colors. These wires are running back and forth, sometimes just from pin to pin. The goal is to get all the information that we need out to the Masso and bring all the information from the Masso back into the box. What we plan on using as the backbone of this system is going to be the actual pins that come from the Masso. The pins are numbered 1 through 25. We're going to go over what those pins are and the fact that they come from the Masso. And we're going to organize our spreadsheet so that we always have a reference where we can go back to the pin numbers. Not all signals get carried through to the ProLight. Some of them need to be converted into different signals inside this box. So you'll see that change. But just be aware, we just keep track, and the framework that we put it on is the DB25 connector that goes to the Masso. Here's where our DB25 connectors are shown in the box. There's 4 of them. They're on the back side of the box. When we look at the back of the box, they're labeled C axis, A and B axis, TTL, IO, and computer. This is what we're connecting. And what we are using are the DB25 breakout boards, the DB9 breakout boards, and the DB15 breakout board. So let's get started. Here's our spreadsheet. And I want to talk about how it's organized. The leftmost box is the DB25 connector. I both label what the color of the wires are in the cable of the DB25 connector, and I also wire what color the wires are once they enter the box, the light machines box that we're refurbishing. So we'll have on the left the Masso colors, on the right the colors in my refurbished box, and then the column in the middle is the one that actually describes what functions are being transferred. Next to that we have the DB15 cable. The DB15 cable has 15 pins. Those pins correlate with the DB25 pins, and for convenience we were able to make pins 1, 2, 3, 4, 5, 6, 7, and 8 match the DB25 pin number. That's convenient, but that doesn't last long because we can't do that for everyone. When you get into the third box, labeled DB9, we've got 9 pins. There we take pins 2, 3, 4, and 5, and we map them to pins 12, 11, 10, and 9. We'll talk about that specifically. When we step into the next box, the fourth axis box, on the back of the machine, this is the one that says TTL-IO. All we're doing is sending 4 wires to a stepper motor that might be connected to a 4th axis. That's all that we're communicating there. So we got 4 wires that are going to go out to a 4th axis. Lastly, on the very most right box, we have the pins in the Masso and how they're connected. So when you go way to the left, you'll see pins 1 through 25, and I make a column of 1 through 25 at 5 different locations on the spreadsheet so we can compare what's going on at pin 25 all across the spreadsheet. So in this last box, that's our Masso connections and what's going on with that device. So let's get to our first box, the DB25 from the Masso. What we did is we purchased a wire or a cable here that had 25 lines going through it. They all are color coded. We have those marked next to the pin numbers. Pin 1 has a black wire, pin 2 has a brown wire, and it goes from there. In the middle, it says what we're doing. So for pin 1 through 4, it's the x-axis. Pin 5 through 8 is the y-axis. Pin 9 through 12 is the z-axis. And pin 13 through 16 is the fourth axis, also known as the a-axis. For each axis, there is a signal. One signal for step with its associated ground, S positive and S minus. One wire for direction and its ground, that's D plus and D minus. So for X, Y, Z, and A, we got D plus, D minus, S plus, and S minus. So the first 16 wires are used to control the motors. Those 16 wires go to the stepper controllers. They don't exit the stepper controllers, they just go into the stepper controllers. What exits the stepper controls are the actual wires that connect to the motor. That's a different type of wire, and they have different colors, and we'll talk about those in different pin setups. After that, we get on leads 17 through 25, and what we've done here is we've worked out what's on the machine. There's a cover, that might require one wire. There's a front stop and back stop, 2 wires. Right and left stop, 2 wires. Top and bottom stop, 2 wires. That's 7 wires. So when we take our 16 wires and we add 7 to that, we get 23 wires. Now, in addition to those single wires, there has to be some way to communicate through that wire. What that wire does for the cover, for instance, is sends a signal to the switch, and then the switch has to be open or closed, and then the signal has to return. So the signal we're sending to all the switches is plus 5 volts. When the switch opens up, the wire that's connected to the cover gets the plus 5 volts going through it. That triggers the Masso, and that's a TTL command that the Masso understands that the switch is now been closed. All the switches are normally open, but here, when this happens, the switch is closed, the Masso shuts down. So those are our stops. Next, I'm in the DB20 or DB15 wire, and we have pins 1 through 15. Notice how the pins start on the left at 1 through 8. That's for the 2 motors, X and Y. And then when you get down to the very bottom, you'll have 9 through 15. The functions are stated there. Now we're having wires that actually go to control the motors. So no longer do we have step and direction. We actually have coils, an A and a B coil. So you'll see XB, XA, YB, YA. On the bottom, we still have what switches are being connected, what micro switches are attached to the wires. And so here we figured out that the cover is on wire 14. That's a wire that is red in the cable. So column 3 is color of the wire in the box. So once you get into the refurbished box, the color of the wire from pin 11 is striped blue. When you're in the cable that's connected to the connector, the DB15 connector, that 11 is yellow red. That's the color of it. So we have both the colors in the cable and we have the colors in the refurbished box. This is where the problem lies. If you want to see what the cables look like, there's a lot of wires running in a lot of directions. It's pretty hard to figure them out, but here is where we do good record keeping, and each wire that I attach to a given pin, I record it, and we know that that wire is yellow red, which you see right on top, or just yellow, or just all white. But at any rate, we know what pins those wires are attached to on the cable. Once you enter the refurbished box, the color changes, and we have those labeled too. So we always know what the color are on the inside of the box for the connector and on the outside of the box in the wire. The next box is the DB9 connector. There I have the pins numbered 2, 3, 4, and 5. Those are the motor wires. The color of the wires are gray red, gray white, gray black. In a similar fashion, the colors in the box for pins 6, 7, and 8 are red, blue, and white. If you want to know what those pins do, go back over to the DB25 connector and you can read what is the function of those pins. Next is the 4th axis DB9 connector. Very straightforward. 4 wires going out to the A coil and the B coil. The colors inside the box are green, black, white, and red. We haven't made up a cable yet, so I can't comment on what the color of the wires is in the cable. Inside the Masso, it's so straightforward. There are exits for step and direction. There are connectors for inputs 1 through 9. The inputs are on top of the box. The step and direction are on the bottom of the box. Starting with the x-axis, I labeled the wires 1 through 16 to accommodate for axis X, Y, Z, and A. Wire 1 is step, wire 3 is direction. For Y, the first 2 are step, the second 2 are direction. Very straightforward. We get through all 16 wires. On the bottom of the Masso board is where the motor control signals come. On the top of the board, starting on the left, there's inputs 1 through 9. And there I have them labeled as input 1 is actually being used by a button on the front of the Masso. Input 2, and that would be the red button. Input 2 is being used by a button on the front of the Masso, and that would be the green button. The first available input is pin 3. What I did with my wires from that point on is input pin 3 is for the cover. Input pin 4 is the left stop. Input pin 5 is the right stop, but we didn't use it. Input 6 is the back stop, again, but we didn't use it. Input 7 is the front stop. Input 8 is the bottom stop. And input 9 is the top stop. The top stop is Z home. The left stop is X home. The front stop is Y home. The 2 that we didn't use, the right stop and the back stop, are what happened when the machine signals the controller that it's going off the rails. We can do that in software, and we don't have to do it with a switch. The other thing is, the way that it's wired is that the right stop is in parallel with the front stop. And so when that right stop gets triggered, not only does it get triggered, the front stop gets triggered, and that confuses the Masso, so we didn't hook it up. The back stop is in parallel with the left stop. Because of this, the machine also gets confused if you trigger that. So we did not hook that up. These are the 3 switches I talk about in the video that we probably don't need. And what's interesting about using the Masso, it's not that easy to use them, because when one of them goes, it signals another switch has been triggered too, and the Masso gets confused and shuts down. So in essence, in a nutshell, that's how we did the wiring. And finally, here's a picture of the Masso controller showing the inputs on the upper left and the stepper controller on the lower right. And there we have it. I want to thank you a million for putting up with me through this entire presentation. Hopefully I've explained things where you can see what's happening with these spreadsheets. Hopefully they're going to be of value to you if you do decide to do something like this. I do have to remind you that most of these ProLights are wired differently. I've seen 3 of these wired from beginning to end, and you cannot count on the color of the wires and the cables, nor anything else. So you just have to work this table out yourself. What I've come up with here is just a mechanism to organize things so you can understand them. And hopefully this will be beneficial for you. You have a good day.